So we had come till this equation, that is equilibrium constant is equal to the product of the product concentration raised to their proper powers divided by the reactant concentration raised to their proper power. These powers are actually corresponding to the number of the molecules which are actually or which are present in a stoichiometrically balanced chemical equation. Now here this equilibrium constant, while expressing the equilibrium constant, instead of considering the concentration terms, the concentration is expressed in activity rather than in the concentration term. The activity terms are used, and these activity terms are not having, or the activities, these are not having units, and hence therefore the equilibrium constant is also a unitless quantity. Let's see how. What is exactly the activity is? Actually, how the activity is being calculated, the concentration of the reactant or product, whatever the molecules are involved in the reaction, their concentration divided by standard concentration of 1 molar or 1 moles per liter. This ratio is called as the activity. And actually, when the reactants are either liquid or solid, this type of activity is calculated. If your reactants are gaseous, then the pressure, partial pressure of the gas divided by pressure, standard pressure of 1 bar. A standard pressure of 1 bar. This is how the activity of the gases is calculated. To calculate the activity of the liquids or the solids, this type of the equation is used. The concentration of that liquid molecule or solid molecules divided by the standard concentration of 1 moles per liter. Now, related, as these two are the ratios, this is also in moles per liter, and these are in a whatever the concentration is used here. This is also in bar, this is also in bar. So this moles per liter and that moles per liter get cancelled, and hence therefore activity is a unitless quantity. Here also both the pressure, so both the unit will get cancelled, hence activity of the gases, that is also a unitless quantity. So this concentration, these are substituted with activities, and as the activities are unitless quantities, therefore the equilibrium constant, it is also the unitless quantity. Now, for the activity of the solid, liquid and the gases, certain rules are used. What the rules are there? The first rule is pure liquid or the pure solid, their activity is considered to be 1. This is the first rule. The activity of the pure liquid and the pure solid, it is considered to be 1. To calculate the activity of the solid or liquid, their concentrations are divided by the standard concentration of 1 moles per liter. To calculate the activity of the gases, their partial pressures are divided by the standard pressure of 1 bar, and then their activity is calculated. In the mixture of gases, if the mixture of gas is present, therefore the activity of individual gas is obtained from this formula. Even the gaseous contents, when they are in the pure form, their activity is also taken to be 1. So these are some rules to calculate or to consider the activities. Now, the types of the equilibrium. We are going to see the types of equilibrium. There are 2 types of the equilibrium: homogeneous equilibrium and heterogeneous equilibrium. heterogeneous equilibria. Now, what is homogeneous equilibria? The homogeneous equilibria is the equilibrium reactions where the reactants and the product both are in the same phase. That type of the equilibria are called as the homogeneous equilibria. For example, here in this reaction, the products are the hydrolysis of ester. Here, these all are in the liquid form. Here, acid is used as the catalyst, which is also in the liquid form. The reactants and the product both are in the same phase, that is the liquid phase. So this is the example of the heterogeneous equilibrium. Homogeneous equilibria, all are in the same phase. What is heterogeneous equilibrium? Where the reactant and the product, they are in the different phase. Such type of the chemical equilibrium reactions are said to be the heterogeneous equilibria. For example, decomposition of sodium bicarbonate. This gives sodium carbonate plus carbon dioxide plus water. So this is something the reactant and the product, when they are not in a same phase, in such equilibrium reactions are called as heterogeneous equilibria. This is in a solid phase, while the products are in a solid and the gaseous phase. So these were the types of the equilibria. The rest of the matter we will take next time.